Hello. Now let us begin with the third lecture. In this particular lecture, what we are going to discuss is congruency of triangles and the first test of congruency of triangle, which is SAS. So when we start discussing congruency of triangles, we need to understand what the triangle is, and therefore let us understand few terms. If we consider triangle ABC, A, B, C are vertices of the triangle. All these things are known to you, but just I am revising just to check whether we are on the same plane. A, B, C are vertices of the triangle. AB, BC, CA are sides of the triangle. Then we will call side BC is opposite of vertex A. Side CA is opposite of vertex B, and side AB is opposite of vertex C, opposite side of vertex C. Angle ABC, angle BCA, angle CAB are interior angles of triangle ABC. If sometimes it happens that at some vertex only one angle is present, say for example at B or A or C in this case, and therefore sometimes it can be written as angle B instead of angle ABC. Instead of angle BCA, it can be written angle C or angle A, just to reduce the notation. Okay. When we say angle ABC, we say angle ABC is included angle between sides AB and BC. When we say angle BCA, we say that it is included angle between BC and CA. Angle CAB included between CA and AB. Similarly, side BC is included between angle B and C. Side CA is included between angle A and angle C. Side AB is included between side angle A and angle B. So these notations we will require to discuss the congruency of triangle. Okay. So now let us get into when do we say two segments are congruent. Let me check. AB, segment AB, the notation that we use to write congruency is this. So segment AB is congruent to PQ. Suppose I want to say this, then what must happen? Then if both of them are segments, then their lengths must be equal. So segment AB congruent to segment PQ implies both ways. AB is equal to PQ. First lecture we have seen that this is segment, this is its length. So if two segments are congruent, which that means their lengths are congruent. And when this double-sided arrow comes, we in maths say it is if and only if. If and only if means you can go from this side to that side, and you can come back from that side to this side. So if I have two segments whose lengths are equal, AB is equal to PQ, then I can say two segments are congruent. Similarly, when do I say angle ABC is congruent to angle PQR? Similar to that of segment, I can say angle ABC is congruent to angle PQR if measure of angle ABC is equal to measure of angle PQR. If and only if. So if two measures of two angles are congruent, same, equal, then the triangles, then the angles are congruent. So two segments are congruent, two angles are congruent. So for congruency of two triangles, we will require these two definitions. Now, suppose I have two triangles, triangle ABC and triangle PQR. In how many ways I can compare these two triangles? In fact, 6 different ways. I can compare ABC with PQR, with PRQ, with QPR, with QRP, and with RPQ and RQP. So these are 6 different ways through which I can compare two triangles. Actually, two same triangles I can compare. So what is the difference between all of them? Are they same? No, they are different. Let us check, say for example, triangle ABC is compared with triangle QRP. That means vertex A is compared with vertex Q. Angle A is compared with angle Q. Angle B is compared with angle R. And angle or vertex C is in correspondence with vertex P. Okay. So in other words, angle A is corresponding with angle Q, angle B with angle R, angle C with angle P. Segment AB is in correspondence with segment QR, segment BC is in segment RP, and segment AC is in correspondence with segment QP. So this is what is the meaning of this fourth comparison. And of course it will be different for all the 6. Therefore, even if I have two triangles, they can be compared with each other by 6 different ways, and every method of comparison is going to be different than the others. Okay, therefore what we normally say in congruency, the sequence of these letters and the sequence of these letters must be absolutely right, otherwise it will mean something different. Okay, so this is what is all about correspondence. Now the time has come, we have to define what do we mean by two triangles are congruent. So let us first draw two triangles which are congruent in one particular correspondence and write down its definition. Suppose we want to say triangle ABC and triangle PQR are congruent. So again, this statement is also going to be if and only if triangle ABC is congruent to triangle PQR. This is what we want to say, we want to define. So we are in the process of definition. So definitions are always if and only if. We can define whatever we want, but then it has to work from both ways, from here to there and there to here. So when I want to say triangle ABC is congruent with triangle PQR, what should happen? Every element of triangle ABC correspondingly should be congruent with the other element of triangle PQR. So 1. Angle A must be congruent to angle P. 2. Angle B must be congruent to angle Q. 3. Angle C must be congruent to angle R. 4. AB, side AB must be congruent to side PQ. 5. Side BC must be congruent to side QR. And 6. Side CA must be congruent with side RP. Then we say two triangles are congruent. So this is definition. If two triangles are congruent, then these 6 elements are equal. 6 elements are congruent. If these 6 elements are equal or congruent, then the triangles must be congruent. Okay. Now the question is, every time we want to show two triangles congruent, is it necessary that all the 6 elements are required to be congruent? And you are aware that it need not be. So suppose we start drawing triangles. Suppose I ask you to construct two triangles. One ABC with side AB is equal to 5 centimeters, which is equal to PQ. And then complete the triangle ABC. I am giving you only one information, that is side AB. Then many different triangles can be drawn. It is not necessary that by giving only one information about side, you all will construct exactly same triangle. So only giving out of 6 elements, giving only one element will not create two congruent triangles. Hence we need to give some more information. Suppose I give you segment AB is 5 centimeters, segment BC is 7 centimeters, and they are correspondingly equal to PQ and QR. Still we will not be able to complete the triangle because everyone can draw still different triangle, because the angle B, whatever we take, if it is not specified, everyone can take different angle and produce different triangle. So by giving two sides, I cannot produce congruent triangle. By giving one side and one angle, suppose I give you side AB and angle B 60 degree, still I cannot produce congruent triangle because the point C can be taken anywhere on the ray BC and therefore congruent triangle will not be produced. Every one of you will not draw exactly the same triangle. So two sides given, we will not get triangle which are congruent. Two angles given, of course we will not get, and one angle and one side given, also we will not get congruent triangles. Therefore one is not sufficient, two is not sufficient. Now let us try with three, and we know that all the tests of congruence are such that they require three elements, and the moment you get the three elements, triangles become congruent. So what is there today is the first test of congruence. Side AB is given. It is said that angle B is congruent to angle Q, and it is said that side BC is congruent to side QR. If these three things are given to be congruent, then two triangles are congruent. So this is first test, side, angle, side, and the angle which is being given is included angle between the two sides which are given. So if two sides are given and one angle which is included is given, correspondingly same information for other triangle is given, then we can say by only these three things, that means AB is congruent to PQ, BC is congruent to QR, and angle B is congruent. So instead of using 6 elements, if we use these 3 elements, 2, 4 and 5, we still can claim that triangle ABC is congruent to triangle PQR. That is what we call test of congruence SAS. And now because we have used only 3 elements of congruency for proving two triangles congruent, automatically remaining 3 elements, angle A becomes congruent to P, angle C becomes congruent to R, and side CA becomes congruent to RP. So we get back, because we have used only 3 elements to prove triangles congruent, but congruency of triangle means all 6 elements. Therefore we get back, we deduce remaining 3 elements of the triangle also must be congruent. That is the advantage of congruency. You use small information, you use only 3 elements, two triangles congruent, and get back 3 more elements as additional bonus. Now historically this has been the first test of congruence, and it is very easy to imagine that if we start drawing these triangles, AB congruent to PQ, included angle equal, and BC congruent to QR, and then join AC and PQ, then we are going to get congruent triangles. So it was very natural, it was very obvious that you are supposed to get congruent triangles by doing this construction. But whatever theorems and whatever postulates are available before proving this test, SAS, even Euclid tried to give proof of this particular congruency test, SAS, and still till date that proof is also not acceptable, and hence historically SAS is assumed to be a postulate. Now let me just tell you what is a postulate and what is a theorem. Postulate is a statement which is assumed to be true without proof. And it is a simple statement. We all can understand the meaning of that statement. And the statement is supposed to be true without proof. Nobody can question that why is this statement true? Give me a proof. Nobody can ask that question. And all of us will agree that that statement is correct. In that case, we say that that statement is postulate or axiom. But the statements which are not postulates and still they are true, there we are required to prove them using postulates or previously proved theorems. So if we can prove a statement by using previously proved postulates or theorems, then that statement is called theorem. So incongruency criteria, incongruency tests, we have total 5 congruency tests, out of which SAS is the first and SAS is a postulate. Now what thought experiment Euclid has done to convince all others that we can consider SAS as a theorem, but still that thought experiment is not accepted mathematically. You can go through the notes, check what step-by-step procedure, what thoughts we are supposed to put in place is given, and it is quite convincing that using that procedure we will produce 2 congruent triangles, but the language cut ABC and put it on PQR, they will match. This type of understanding or language is not acceptable in mathematics, and therefore it is not granted status of theorem, and hence till date SAS is considered to be postulate. So go through the Euclid's thoughts experiment, go through the notes, and it is interesting to read how he has step by step explained why SAS should have been the theorem. Now we will solve one problem on application of SAS, and we will figure out how the remaining 3 elements help us. The problem is, say AB is a segment and we have a perpendicular bisector of AB which bisects and is perpendicular. Bisects means it makes 2 equal parts. Let this point be M, and this is perpendicular bisector, so it is a line and it is at 90 degrees. So the problem is, if we take any point on this perpendicular bisector, let P be any point on perpendicular bisector, then P is equidistant from A and B. To prove that, PA equals PP. So we join PA and PB, and we know now that there are 2 triangles in this picture. So systematic proof for this particular problem, let me show. Statement number 1, consider triangle AMP corresponds with triangle BMP. 1. Segment AM congruent segment BM. Given. It is given that it is a bisector. 2. Angle AMP congruent angle BMP. 90 degree given. And 3. This is the element. Every congruency problem you are supposed to use your brain and find out the third element. 2 elements are normally given. Third element is supposed to be found out. So here the third element is MP congruent to MP. Comma. So now I have completed the 3 required elements and they are in the order SAS. Therefore by SAS, triangle AMP congruent triangle BMP. Now this implies 4. Actually I have used 2 sides and 1 angle for proving triangles to be congruent. Therefore I have 1 side and 2 angles available, which are available because of this congruency, but I require only 1. Therefore 4th, side PA congruent side PB by corresponding side of congruent triangle. So this is our last statement, which is same as that of this. PA is equal to PB, and therefore 1, 2, 3, 4, 5, 6 liner proof for this particular problem. Nothing less, nothing more. All important things, reasons why your statements are true, and correspondence. Correspondence is important. So this is how, if you are proving two triangles to be congruent, this is how that it has to be done. This is how the proof needs to be written, and it is very quick, it is very small and concise. Okay, so now you solve. There are, I think, 5 problems in the homework. Go through the lecture notes, because see, covering word by word what is written in these lecture notes is not possible in the lecture, not only in video lecture but in actual classes also we cannot do that. So it is very important that you read the lecture notes completely, find out whether you have understood it or not, and then try to solve the homework problems. 5 homework problems, solve them. Thank you.